So the last lesson for Unit 3, 3-8. 3 vocabulary words: union, intersection, and disjoint sets. We're talking about Venn diagrams, and the union of two sets in a Venn diagram contains all the elements. Symbol, oddly, looks like a U. Intersection contains only elements common to every set, and the symbol is the upside down U. Disjoint sets, which apparently has no symbol, sets with no elements in common. Now, we are going to fly through this lesson. Here we go. Problem 1. In your left pocket, you have a quarter, a paper clipping, and a key. In your right pocket, you have a penny, a quarter, a pencil, and a marble. The union of those two sets includes all of those things: quarter, paper clip, key, penny, pencil, marble. Done. Don't worry about got it, number 1. Go right on to page 215. Problem 2. They give you 3 sets: x, natural numbers less than 19, y, odd integers, and z, multiples of 6. What is the intersection of x and z? So this has to be a natural number less than 19 and a multiple of 6. Well, there are 3 of them: 6, 12, and 18. What is y intersection z? That's this set and this set. So we need an odd integer and a multiple of 6. Well, you remember from your multiplication divisibility rules, there is no multiple of 6 that's odd. They're all even. So that is an empty set. Do not worry about got it, number 2. Go on to problem 3. Problem 3 shows what I think is a pretty funny picture of backpacks for camping. Now, if you've ever been camping with a backpack, I suspect it was a lot more full than these are. But at any rate, the point is they want you to look at this Venn diagram. This kind of picture is called a Venn diagram. I'm sure you've seen them before. And what they are doing is listing all the things that they see in each backpack, and they want to figure out what is common to all of them. I do not even want you to do got it, number 3. I want you to move on to problem 4. So problem 4 shows us we've got 500 commuters, 200 drive, 125 both drive and use public transportation. How many commuters take public transportation? So they are using this kind of math to solve this problem. You know that you have 125 that do both drive and take public transportation. So you subtract 125 from 200, because you know you have 200 people that drive, which gives you 75 people that just drive. And then they continue on to figure out that there are 300 people total that that use only public transportation. Okay? Similarly, I want you to try and set up got it, number 4. You're going to draw me a Venn diagram. 30 students total. 20 are honor students, 9 are both officers and honor students. How many are officers but not honor students? You go ahead, draw your Venn diagram, come back and find me when you've got it figured out. So you should have something that looks a little bit like this. We know that there are 9 in the intersection of both groups. We know that there are 20 honor students. That tells us that there are 11 that are just honor students, 9 that are both. We know that there are 30 students total, so if we have 20 students taken care of, how many are left? 10. And that goes over here. So there are 19 students that are officers, there are 20 students that are honor students, that are 9 that are both, 10 of one, 11 of the other. That's it. Let's move on to number 5. So I have to say, problem number 5 kind of made me laugh because it pulls so many different strings together, threads you've been working on through this unit, and ties them all together and says, this is why you are working on this now. So we have an absolute value inequality, and they want you to use set builder notation to show your answer, and they want you to show if it is a union of 2 sets or an intersection of 2 sets. Let's go through this kind of slowly. 2x, the absolute value of 2x minus 1 is less than 3. So they wrote it out as a compound inequality, think about how we could have written this out from what you learned with the last section. They took exactly those same things and just arranged them in a slightly different order. Now they're solving this simultaneously, so to get rid of this minus 1, they have to add 1 to the middle, to the left, and to the right. So this becomes minus 2. Identity property, that becomes just 2x. That becomes 4. Then you have to divide each side by 2. So we have each section by 2, I should say. So we have negative 1 here and 2 here. So this is how they express the solutions. Then they break it down and they say, well, you could write the same thing as x is greater than negative 1 or x is less than negative 2. Once you have that, you can write it as set builder notation. X is greater than negative 1 can be written like this. X is less than negative 2 can be written like this. And then the only question is, which one is that? A union or an intersection? Well, we need both of these things to be met, so this is going to be an intersection. Go back and watch this whole process again if you need to. I want everybody to do got it number 5. It's 2 parts. It's a little bit hairy. This one is an absolute value inequality. You might have to refer back to that chart that I gave you in the last section to figure it out. You're going to solve these, and then you're going to write the solution in set builder notation as either a union or an intersection. Go for it! Okay, I don't like to do all this simultaneously. I'd rather break it up because I'm just afraid I'm going to make a mistake if I try to do it all at once. So I end up with 3 is less than or equal to x and x is less than 6. When I turn that into set builder notation, it looks like this. And then, since both of these things have to be true, this is an intersection. It has to belong to both groups. Let's try letter B. So I went back to that chart on the other page from the last lesson so that I made sure that I didn't make a mistake. This means your 2 problems are 4x minus 6 is greater than 14 or 4x minus 6 is less than negative 14. Now that I've got both of those, I can work through them and end up with x is greater than 5, x is less than negative 2. Here's my sets. Here are my sets in set builder notation. This is an or. We don't need both of them to be true. In fact, we can't have both of them true. So this one's going to have a union because it means everything for either of those. Last but not least, I would like you to complete the lesson check on page 218, number 1 through number 9.